especially for this things that we're going to do right now. Like the graphing calculator just zooms in so nicely for us. Hopefully I can make it work. So bear with me as I too am new to Desmos, but I will show you how much I love it in a moment. Okay, so this is an easier one. A farmer wishes to enclose a rectangular region. He has 120 feet of fencing and plans to use one side of his barn as part of the enclosure. Determine a function to represent the area. What are the restrictions on x? Excuse me. Graph the function. Interpret 18, 15, 12. And what is the maximum area the farmer can enclose? Okay, so these are all the different parts that they would ask you for this question. So I would like to draw this because I think it's important that you understand what we're talking about. I have this barn, and he is going to put a fencing around it. And we know we were told the fencing is 120 feet of fencing. So I know I can call this side X. Then I can call this side X, right? Because it's rectangular, so it's got the same on both sides. If this was 10, this was 10. How would I figure out this? Well, this would be, stop, Jack. This would be, the whole thing right here is 120. This side was already used, and this side was already used as X and as X. So this side right here, this bottom part, would be 120 minus the two X's that I have. Now, how do I determine a function to represent the area? So very easy. Area, if you remember, I'm going to call it A of X. Sorry. A of X is equal to your length times width. Length times width. So 120 minus 2x times x. And then you just want to FOIL it out. So 120x minus 2x squared. That is a function that will help you find the farmer's area. Okay? Now, second question. So we just did part A. What are the restrictions on x? So here's how you develop restrictions, kind of what we just did before. You don't want to have this side being a measurement of 0 feet. That makes no sense then. You can't create a fence, okay? So we know that we definitely want x to be bigger than 0. We want it to actually have a length or a width, okay? We also want this width to be bigger than 0. We don't want it to equal 0. That would be silly. So we want 120 minus 2x to also be bigger than 0. So solve this inequality. 120, I'm going to bring the minus 2x over, put greater than 2x, and then divide by 2. 60 is greater than x. So I'm going to write that the other way. X is less than 60. So here's my restrictions on x. My restrictions are that x has to be bigger than 0, but less than 60. Bigger than 0, but less than 60. The way to write that, if I want x to be less than 60, but bigger than 0, that would be how to write your restriction. Okay, so that is part B. Between 0 and 60, oops, sorry, for my values of x. All right, now let's move on to part C. We're going to graph the function, and that is going to go to good old Desmos. And like I said, this is new for me. Bear with me. I'm still learning it, but I think it's pretty cool. 120x. They have a keyboard down here. Minus 2x squared. Whoop, that's not what I wanted. And type y equals Okay, yes. Now, I got to zoom out because look at how big this parabola is. Whoa, this is crazy. I can see it's all the way up here. If I put my cursor over it, it's at 30,1800. So I actually want to change the window so it kind of looks better, looks more like a parabola. And the way that I've learned how to do this is you go to the wrench and, sorry, my little meeting's in the way here. I want my y-axis to go from, let's see if I'm, hold on, I gotta move you guys over. I want my y-axis to start at 0. Why aren't you working for me? Maybe I have to type it here. 0. Here we go. And then, no, it's being complicated because I got too many things going on. Hold on. Let me hit 0. Let's see if that works. And then let this be, it's still not working. Wow, this is, there we go. 0. And then I want my y, the highest value of y to be, I mean, we'll go by 2000. And then the step, the interval that I want it to go up is, I mean, we can make it go up by hundreds if you want. No, that's not so good. Maybe 500s. This is kind of like changing your window. But now I've lost my picture. My dog is being very bad right now. Okay, let me redo this. I told you I'm very new with Desmos, but it was working beautifully when I was trying it before. Of course, now it's not working well. Minus 2x squared. And let's see if it works up now. Jack, you are driving me crazy. Oh, I've changed everything now. All right, if this isn't working, I'm going to go to my thing, and I'm really sad because it was working so nice for me. Oh, here it is. I'm just going to go back to the regular one. Get down. Sorry about this, y'all. I got a crazy dog, and then I'm learning how to do this. I'll figure it out in a minute, but I'm pretty sure like we can see from the graph here how to graph it. And I'm actually going to go back here and draw it a little bit better on my paper. There we go. Okay, so I do know that it goes pretty high up here. And I'm not going to draw it too crazy. I saw that I did have a maximum point, and I'll go back to it because Desmos is pretty good about that. You can actually just click on it, and it says 30,1800. And I do want to get this point down here where it's at ground level 0. So that point is 60, 0, and then 0, 0. I'll figure out the wrench thing afterward, but I know it works well. I'm kind of bummed that I'm not figuring it out right now. I don't want to waste your time. But anyway, we got a pretty decent picture now. So let's look here. So we've graphed it. Now we need to interpret for part D 18, 15, 12. What does 18, 15, 12? And it's kind of like, what does this 30, 1800 mean? Okay. Remember, this is your X and this is your A of X. So this is X referring to the length or the feet, the side length of the barn. 1512 would be your A of X or your area with a side length of 18. area in square feet, I guess we would say, when you have a side length of 18. So that would be part D. And then part E says, what is the maximum, ooh, there's that word again, maximum area the farmer can enclose? Well, maximum, we know, refers to the max right here. The highest amount of area that the farmer can enclose would be right there at the vertex. It would be 1,800 maximum area, well, I should say square feet. And so that's how you do that one, minus my Desmos blunder here. I'm very sorry about that, but I know there's a way to fix it, and hopefully I can fix it with the next one soon. But that's a very similar question that you'll see on homework tonight. All right, let's do number 2. Now I'm gonna set you up on number 2, but I'm telling you right now, it's a doozy. It is a crazy one, but you'll see it, so you need to be prepared for it. Okay, so a machine produces rectangular sheets of metal satisfying the conditions that the length is 3 times the width. Furthermore, equal size squares measuring 5 inches on a side can be cut. Is that the resulting piece of metal can be shaped into an open box by folding up the flaps. Determine a function to represent the volume. What restrictions must be placed on X, similar to what we just did. If specifications call for the volume of such a box to be 1435 cubic inches, what should be the dimensions of the original metal piece? And then graphically, what dimensions of the original metal will assure a volume greater than 2,000 but less than 3,000? Okay, and again, you could do this in your graphing calculator, but hopefully Desmos will be cooperative with me. So I just kind of want to draw this out. You have a rectangular sheet of metal, and we were told that the length is 3 times the width. So if I call this X, this length would be 3X, and so around. We were also told that equal size squares measuring 5 inches on each side. So I have a square here measuring 5 inches on each side, going all the way around. And they're going to cut them so they can fold up those flaps and make a metal box, essentially. Okay? So maybe I can draw it like this. Like you could see that this would be the bottom of it. So another way to kind of draw this would be, you're going to have this box. I think sometimes it's important to look at it so you can understand what's going on. I'm taking this metal sheet, I'm cutting out these 5 inches, and I'm folding it up to make this beautiful box. All right, so now we've got to label these sides. Jack, get down. So how do I label these sides? Well, this side, obviously going up, this fold up right here, this height would be 5 because it's the 5 inches that I'm cutting. Now, what about this side right here and this side right here? Well, if this whole length is X, this whole length right here, but then I cut 5 inches and cut 5 inches, what would be that little base right here, this side right here? This whole length was, let's say it was, 20, and then I took away 5 and I took away 5. So that's actually how you label it. X minus the 10 inches that you cut. So then this way, this whole length is 3X. But again, I cut these 5 inch metal pieces away. So that side right here would then be 3X minus 10. So now we have all of our length, our width, and our height. Our length, our width, and our height. And that's how you find volume. If you don't remember how to find volume, it's volume equals your length times your width times your height. And yes, you've got to FOIL this out. I'm going to save us some time and FOIL it out for us. 15x squared minus 200x plus 500. Now, that was part A. All that to do part A. But I promise you the question you'll get will be very similar. You just want to kind of look to see, are you subtracting? Are you the 5? Maybe it's a 2 here, you know, something like that. All right, now we need to know what are our restrictions. Again, restrictions being we don't want a side length of 0. We want it to actually be a positive number. So for part B, I'm going to make sure that each of these side lengths, x minus 10 and 3x minus 10, are bigger than 0. So x minus 10, we want to make sure that's bigger than 0, and we want 3x minus 10 to also be bigger than 0. So x has to be greater than 10. On this side, 3x is greater than 10. X is greater than 10 thirds. Now let's just real quick talk about this. 10 thirds is roughly like 3 1/3. So this part is saying I want x to be bigger than 3 1/3 feet. But this part is saying no, I need x to be bigger than 10. You want to choose the one that's going to work for both. So we're going to choose this as part of our restriction. We want our x to be bigger than 10. We want our x to be bigger than 10. That's the one for part B. Those are the restrictions placed on. All right, let's do part C. If specifications call for a volume of such box to be 1435. So now they're telling you we want this volume right here to be 1435. So we want 15x squared minus 200x plus 500 to be 1435. What should be the dimensions of the original metal piece? I'm going to tell you right now. This is a doozy of a problem right here to do. To factor into FOIL, and you could do quadratic formula, but you've got to get this over to that side. 1435 minus 500 is 935. So minus 935 equals 0. And like I said, you could do quadratic formula. You can factor out a 5 from all of these right now, maybe to make the numbers smaller. So 5 from 15x squared is 3x squared, 40x, and then minus 187. So those are a little bit smaller to put into quadratic formula. This is actually, I hate to tell you, it is factorable. Not hate to tell you, I'm just going to tell you it is factorable. But, and again, just to save you time, I probably would, if I were you and you didn't feel comfortable about factoring, I'd probably use the quadratic formula. But to factor this, it would be 3x and x, and then it's going to be 11 and 17 here. And then you set each of these equal to 0. So you'd have 3x plus 11 equals 0, and x minus 17 equals 0. So x is 17. This one you would get a negative number for x. And again, we can't have it. We have x to be restricted here. So x is going to be 17 would be the length, but it asks us specifically what are the dimensions. So it would be 17 would be our x, so we put 17 in for x here. 17 minus 10 is 7. 17 times 3 is 51 minus 10 is 41. And then 5. That would be the dimensions. I'm saving, I just want to let you know, if you're questioning how I got this right here, how did you get this number? How did you know to factor? I have already worked it out. I was trying to save us time, but I can show you how to do this with quadratic formula. It's just going to take a little bit of extra time on the side. And I know some people feel very comfortable and they're like, yeah, I know how to do it. We'll work it out on the side, but I can do it for you after class if you want me to. And then part D, graphically, what dimensions of the original metal will assure a volume greater than 2,000 but less than 3,000? So I'm going to go to Mr. Desmos. Work for me, buddy. And I did this before and it was working fine. I'm going to put in my original function, 15x squared minus 200x plus 500. And I mean, it's x squared minus 200. Yeah. Okay. So it's really, you can see there's the graph. It's really, really crazy looking. It's according to the story, it says, I want a volume that's greater than 2,000, but less than 3,000. Okay. So now I hope my wrench will work for me. If not, I'll do it in my other thing. I let the x-axis be 0. From 0 to 25. And then the y-axis, again, the question was to go from 2,000 to 3,000. So I kind of chose the y to be 0 to, I went up to 5,000. Okay, yay, it kind of worked for me, finally. Okay, so I'm only working in quadrant 1, if you can see. I mean, I only want my x values, my length of the sides. We already found the x to be 17. So I chose my x values, my length of side to be between 0 and 25. I went up to 25 because I knew I was going to go higher. And then I chose my y-axis here. When I looked at the wrench, I was like, it specifically said it wants it between 2,000 to 3,000. What interval, if you read the story again. So I'm actually going to write 2,000. Actually, I think I have to put y equals 2,000. And then here, I'm going to put y equals 3,000. So when is the volume between 2 and 3,000? So I'm going to look at these points right here. That point and that point. This is why I like Desmos. I was so impressed that it did this. I mean, in the graphing calculator, you'd have to hit a couple of things. You'd have to type 3,000 and 2,000 and then do second calc 5, enter, 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 and get this intersection point. But it gives it to me right away. And look at that right there. I have 18.685, 2,000, 21.196. Again, what does that mean? Because that's part of understanding math. 18.68 is my x value. That 18.65 would be the x that I plug in to get my dimension. 21.196 would be the other one. I want any of these to choose as my x's. So let me go back to my screen here. So when I graphed it, here's what I was doing. I was looking at when x was 2,000, when the y value was 2,000, and when it was 3,000. And I got x value points of 18.7, 2,000. And then this one was 21.2. 3,000. Now, that's not the dimension. Those are the x's. So you actually would have to plug this in for x. 18.7 minus 10 would be 8.7. And then 18.7 times 3 minus 10. So that's 46.1. And then a 5. So anything bigger than 8 by 46.1 by 5, and then less than, you'd have to plug 21.2 in the same exact way. 21.2 in, which would make it 11.2, and then 21.2 times 3, 53.6, and then by 5. All right. So I'm already laughing because I can almost feel everybody right now being like, Miss Aceta, I would skip that question, but don't. At least try to get, you could get at least a few parts of this correct, and it would make you feel really good. I promise you that, because this is a tough question, and I know it's on the homework tonight. So let's just go to our last few. Hopefully they'll be easier. I'm pretty sure they are. I tried to get the tough ones out of the way in the beginning. So let's finish up here. The mat around a picture measures X inches across. The mat is 44 inches long and 27 inches wide. The area of the picture itself is 500 square inches. Set up an equation that expresses the area of the picture in terms of the thickness of the mat. Okay, so again, I like to draw myself pictures because I need to know what I'm talking about. Oh, that looks like terrible. You got a picture here. Hey, here's a guy. Yay. Okay. And we were told, let's see, the mat around the picture measures X inches across. So the mat itself, the mat is 44 inches by 27. And so again, I've got this like an X happening here. Set up an equation that expresses the area of the picture in terms of thickness of the mat. The mat itself is X by X. So again, we're finding the area of the picture. Here's my picture. I know this mat is 44 inches that way. So how could I write an expression for that little portion? Well, it's 44 minus this X minus this X. So that part right there is 44 minus 2X. This side was 27. But then I went an X and an X direction also. 27 minus 2X. So this is my length of my picture. This is the width of my picture. And it says the area of the picture itself is 500. And again, area is length times width. So 44 minus 2X length times 27 minus 2X width equals 500. You don't have to solve it. Thank the Lord. Don't have to solve that one, but you could solve it. I know you could. Okay, but that was all you have to do is just set it up. Probably should have done that one first. Maybe you wouldn't have been tuned me out or something. This is a common one. Height of a ball dropped from the top of a 12-foot deck after t seconds is given by negative 16t squared plus 12. Find the number of seconds that it will take the ball to hit the ground. We've kind of done this before. So if this is our position function, height, in order to be hitting the ground, my height would be 0. Get down, Jack. So I'm just going to set this negative 16t squared. Get down, buddy. Plus 12 equals 0. I just want this height to be 0. When is it going to be 0? So negative 16t squared equals negative 12. Divide by negative 16t squared equals 12 sixteenths, which reduces to 3/4. and then take the square root of it. T equals, now you're not going to put plus or minus because we're talking about time. So we're just going to find out what the square root of 3/4 is. I'm just using my calculator over here on the side. And I get about 0.8668. So that's what happens when the ball is dropped from 12 feet. That was pretty easy. Ground level 0. Thank goodness, right? Woof. All right, last two. Kite is flying 89 feet of string. How high is it above the ground if its height is 41 feet more than the horizontal distance from the person flying it? Assume the string is being released at ground level. So this one is easy, but this is a right triangle. And they've actually labeled all the things for me. So in order to do a right triangle, we use Pythagorean theorem. So we are going to do A squared. This is your A, this is your B, and this is your C. It actually doesn't matter which one is your A, your B, or your C. Your A or your B, but the C has to be the longest side. So A squared plus B squared equals C squared. So X minus 41 squared plus B, which is X squared, equals C, which is 89 squared. And yes, you've got to FOIL this. X minus 41, this is what you're doing, times another X minus 41. So that would be X squared minus 82X, and then I don't know what 41 times 41 is. 1681. Plus another X squared equals 89 squared, which is 7921. Now set it equal to 0. So I would have X squared and X squared makes 2X squared. Whoops. Minus the 82X. I'm going to minus 7921 over to here. So 1681 minus 7921 is 6240. Minus 6240. Now, I noticed that they all have a 2 that I can actually factor out. It's going to help my quadratic formula definitely be better. 41x and then 6240. I could probably do it in my head, but it's a little late. 3120 equals 0. And then this you could put into the quadratic formula. But I will tell you it is factorable. There's another way to do this. I think I've shown this class, but you can actually go to Y1 and type in this right here, 3120, divide X, and you can go to table, and you can look for, they give you all these numbers, and you can just look for numbers that would make 41. And if I remember, are they pretty far? Oh yeah, it's like, it says 80 and 39 is what I have. So let's see, we're getting closer. 80 and 39 would actually make the 41. So there would, it is factorable. But like I said, you could use quadratic formula. 80, 39, the 80 would be negative and that would be positive. That 2 means nothing because there's no X next to it. You could bring it down, but it doesn't mean anything. So I would have X equals 80 or negative 39. Again, since we're talking about the length of a side, can't choose negative. So 80 would be the X value, and it said a kite is flying. How high is it above the ground? It is 80 feet above the ground. Okay, last and final one. Heart rate of an athlete while weight training is recorded for 4 minutes. The table lists the heart rate after X minutes. Explain why the data are not linear. Find a quadratic function that models the data, and what is the domain of the function. I've done one like this, and I'm going to do it in the calculator. And I'm going to show it to you also in Desmos for those who like the Desmos. I'm finding out there's more of you. But real quick, because I'm so much more familiar with the calculator, I will show you that real quick. So you go to Stat, Edit, and then put this into L1 and this into L2. So Stat, Edit, clear what's in L1, go over to L2, hit clear. So now you have a nice clear L1 and L2. So let's see. 0, 1, 2, 3, 4, 90, 114, 122, 15, 89. And then once you do that, you have to turn the plot on. And the way to turn the plot on is hit second y equals. Right now I have it off. I'm going to hit enter, turn it on, and it should be highlighted on the first one, which is the scatter plot. So let me just write this down for you. Second y equals, turn it on. And then you want to tell the window to only graph your statistics, because that's where you went to stat. So you hit zoom stat, which is zoom 9. And there you go. Zoom 9. And it gives you a pretty good graph. Now that looks, what does that look, linear? No, that is not linear for sure. That looks quadratic. Explain why the data is not quadratic. It's a quadratic regression. Okay, that's for sure. And I think they give you multiple choices on like that part. Part B, find a quadratic function that fits that model. So the way to do that, the calculator will do it for you, is, let's go back to the home screen. Go to VARs. Go to number 5, which is statistics. Let me write this down for you. VARs. Number 5, which is statistics. Arrow over to EQ. Actually, that's not what I want to do. I'm sorry, I was trying to paste something in. Ignore it, ignore it, ignore it. That's not what I want to do. I want to go Stat, Calc, Quadratic Regression. My bad. I'm sorry. There it is. Let me write this again. Stat, Calc, Quad Reg. And then they give you the A, and they give you the B, and they give you the C, and you just plug it in. So you would have y equals negative 8.21 x squared. My B is 32.76. 32.76x, and then my C is 89.77. And that is your quadratic regression. Sorry about this right over here. This is how I'm actually going to get. I can now type this in to my y1. I'm going to type negative 8.21 x squared plus 32.76x plus 89.77. And I'm going to hit graph. And look at that. It just kind of graphs it nicely for you. There we go. And then it asks you to it says, what is the domain of the function? And again, how wide is this function going from? And if we're talking about heart rate, it looks like we're going from 0, even though it's negative. Again, you're not along the x-axis. We can't be negative in terms of time. We're talking about time here. So I would have from x being bigger than 0, that's for sure. And then down here is that, oops, sorry, it's blurry. I want to see what that 0 is there, so I can actually hit Second Calc 0. And let's see if it'll do it for me. If I hit trace, it might actually even come up. Here's left bound. If I go a little further, right bound guess. Oh, no, it won't let me do it there. But I think you just have to estimate it anyway. It's right about trace. Those are just those numbers. Graph. Go back to graph. Thank you. What happened to my thing? Oh, I was hitting Second Calc 0. That's what it was. I'd have to change my window, but it's definitely going to be something that you can see. And actually, I'm going to show it to you on Desmos a little bit better because my calculator is getting a little bit annoying for me. So let me go to Desmos real quick, and we will be over here. Let's get rid of this one. Let's cancel. Let's refresh because I don't want, yeah, reload it. I want a different wrench. Here we go. So here's one I want to show you how to do this one on Desmos. I was really excited about it. If you click this plus sign, you can see all these things here. You can actually enter a table, and you can enter this table 0, 1, 2, 3, 4. Not 5, there was no 5. And then you can type the numbers in, 90, 114, 122, 115, 89. And it should graph it for you. If you hit, I don't know if you noticed what I just hit, but there was a little plus sign zoom fit over in the corner, and it just made it for me. It was so nice. It made all those dots and it fit to my window. I was all excited. It's like over here on the corner. I'm sorry, I hit it too fast, but you'll see it if you type a table in. And then this is even neater. I was super excited about this. You can actually go here and it will type a regression equation like we just did. Like we had to hit all that stuff, stat, calc, quad reg. You can go like this, y, and then you do this sideways squiggle. And then you type a, x, and then hit squared, and then type 1 plus bx 1 plus c. And it's not working for me right now. No, where am I at? Stats. You know, the joys of having it not work for you. Come on, it was working for me so nicely before. I'm sorry, I'm so new to Desmos, but when I see it being done and I tried it out, it was working for me. Maybe if I just go, it's supposed to be y and then sideways squiggle, and it works out for you. Ax squared 1 plus bx1. Oh man, I'm gonna be so bummed because it was working out so nice. I'm sorry, I look terrible right now. Like I don't know what I'm doing, but I don't on Desmos, but I know it worked out so nice when I was trying it out before. But I will figure it out for you. But at least I showed you how to do it on the graphing calculator, but it was really, really pretty. Oh, I'm bummed. All right. I feel like a loser of a teacher tonight, but it is what it is. All right, that's the end. I'm sorry it took so long, and I'm sorry I didn't figure it out and made it nicer for you, but I will next class, I promise. And let me stop this. Oh, don't take my phone. All right, so here's what you're going to do now. Beside laugh that Mrs. Seta doesn't know what she's doing on Desmos. It's so pretty. I'm going to make my own little video about it, but if I can. But you can start your homework right now. Obviously, you got 4 things to do. Sorry about this last lesson. This is the hardest of the lessons probably that you'll have to do. But get to working on that. And if you have any questions, I'll be here. Other than that, you're free to go. Sorry about my lack of Desmos knowledge, but I know it works. Ugh. I'm doing this for you, Ben. I did it and it didn't even work. I'm kind of bummed. Jack, stop biting on it. I got to go back to it now and see if I can figure this out because I'm super mad at myself. You're about to get locked up, bro. Oh, I bet you I know what it is. No, that's not it. No. Y. Sideways.
You figured it out?
I did I had it all beautiful, and I do not know why it's not working.
Come on, you gotta be better.
I'm doing it right now again.
Well, I do have one question for you.
What's up, kiddo?
So I've got this problem laid out in front of me. For the equation of the axis of symmetry, what is that like equation set up with the letters?
X equals negative b over 2a.
X equals negative b over 2a. Awesome. Thank you.
And then you just put it in there and it should give it to you.
Okay, so
I'm gonna figure this out. I'm mad. I had it all figured out. I even wrote myself little notes. And it's not working. And I'm really mad because I was so impressed with it. And I was like, oh my gosh, Ben's gonna be so proud of me.
what's really funny is so my girlfriend's sitting on the other side of my room doing homework.
And she's laughing at my.
Well, no, she can hear you like saying you can't figure it out, and you were like saying that, and I'm in my living room and I screamed, "I swear you better figure it out, Mrs. Seta." And it was like right after that you said, "I'm trying, Ben. I'm gonna get this."
I know. I literally did it for you. Well, it was funny because we ended last class and you're like, oh, I'm like, there's got to be a way to do the table and the regression in Desmos. And I found a whole website on how to do it. And like the way they made it was so easy. And I did it right away. And I was like, oh, this is amazing. I can't wait to show Ben. And of course, now I cannot figure it out. Oh, I know what it is. Oh, crap. Is it Y1? I'm going to be so mad.
Watch. This is what it is.
That's what it is? No!
Everybody already left.
Y1. I'm an idiot. And I even have it. It's Y1. I typed Y. Darn you, Desmos. Look, it came up. Oh, it's so pretty.
Guess we'll have to look at it on Tuesday.
It even grabs it for you, Ben.
Oh, that's so perfect.
I don't know if you here. I'm sharing my screen just because I need you to know I did this for you.
All right, let me see.
And you'll be so proud of me.
Yes. So you just put the numbers. Hold on, let me see what you've got typed in for the first one.
Look, all I typed was Y, and then you type 1, and it actually recognizes it as a subscript.
Okay.
And then you type the squiggle thing that's like next to the number 1 on your keyboard.
Mm-hmm.
And then it all starts giving you this. It starts giving you like all this stuff right here. Like it actually, look, it has all the A, it has the B, it has the C right there.
Okay, gotcha.
This is amazing.
Desmos is better than the calculator.
Desmos is, and then look, you can find the domain point right there, which is 5.8885, rather than going to the calculator. I'm so mad. I'm so mad it was Y1. I am a moron. I'm going to get me a sticker. Ah.
Have you told your Metrolana kids they have to use Desmos yet?
I told him, I go, guys, well, here's the problem, because so most of them have the SATs and the SATs don't do Desmos yet. So
Oh,
I
yeah.
still have to make sure I get them like calculator ready. But my goodness, look at that. It's Y1. I'm literally going to write a 1 right. I have a 1 right there, but I'm going to highlight it even more. I'm so mad. But I did it for you, and I'm actually glad you made me do it because I was like, this is legit.